Here we are trying to understand the concept of limit of a function. So we have to find the limit x is approaching to 2 for a function f of x, where the function is described as x square minus x plus 1. Again, how do we read this? That we have to find the limit of a function f of x when x is approaching to 2. So to answer this question, what we are going to do is, here we are going to plot x values and here we are going to plot y values or f of x. Okay, so here we have when x is approaching to 2. So on x number line, somewhere here we will mark 2. Remember that this 2 is not the middle of the real number line. It's just that we needed 2, so we have marked 2 here. Now when x is approaching to 2, so x could approach to 2 from the right of 2 or x could approach to 2 from the left of 2. Now x could be any number. When it is approaching to 2 from the right hand side, let's say we have some number here 2.005. So for 2.005, what would be the value of f of x? Whatever is the value of f of x, we will mark it here. So when we plug 2.005 in the function f of x, which is here x square minus x plus 1, we get the value 3.0150. Let's get closer to 2 by picking one more value on the right hand side. This time we take 2.001. When we plug this value 2.001 in the function, we get 3.003. So we can see that as we are approaching to 2 from the right side of 2, the values of the functions are getting closer to approximately 3. See, 3.0150 and 3.003 are not the values of the function calculated exactly at x2, but they are the values of the functions at x's which are closer to 2 but on the right hand side of 2. Now let's see if we pick a value closer to 2 but on the left side of 2. But we have to stay very close to 2. Let's say this time we pick on the left of 2 1.995. For this value of x, the value of the function we get here is, by plugging this 1.995 in the function, we get 2.98. Let's get closer to 2 by picking one more value but on the left hand side of 2, which is 1.99. We will see that the value of the function will be 2.99. Now again look that when we picked values closer to 2 but from the left hand side of 2, the values of the functions were 2.98 and 2.99, which are approximately closer to 3 again. So what we can say is that when we are approaching to 2, or when x is approaching to 2 from the left hand side of 2, the function is approaching to 3. Again, the concept of the limit does not say what is the value of the function exactly at 2. It asks when x values are getting closer to 2, both on the right hand side of 2 and the left hand side of 2, where does the function approach? So this time we can see that when we pick values on the right hand side of 2 but stay very close to 2, like 2.005 and 2.001, and when we pick the values closer to 2 from the left hand side of 2, the function values are approaching towards 3. So in this case we will say that limit of the function, and function here is x square minus x plus 1. When x is approaching to 2, we have seen that it is approaching towards 3. The function is approaching towards 3 when x is approaching to 2. Now, if I write this f at 2, so it means what is the value of the function exactly at 2. It's not the limit of a function when x is approaching to 2. So it's the value of the function exactly at 2. In this case, you will simply consider the function f of x, and in the places of x's you will put 2, which in this case gives you 4 minus 2 plus 1, which is 3. So what we are seeing is, in this particular instance, the limit of the function at 2 and the exact value of the function at 2 are same. So this is the concept of the limit. Let's say we have to find the limit of a function x square minus x plus 1 at 1. Again, we are going to mark the x values here, and we are going to mark the y values or f of x here. Since we have to find the limit at 1, so it means that x will approach to 1 from the right hand of 1 and from the left of 1. And let's pick a value on the right of 1 but closer to 1. Let's say we are picking the value 1.002. So at 1.002, let's see what is the value of the function. We get 1.002004. When we plug 1.002 x value in the function x square minus x plus 1, this function, we get 1.002004. We can see that this is approximately equal to 1.001. When we plug this value in the function, we get 1.0010, and again we can see that this is closer to 1. So we can see that when x is approaching to 1, on the right of 1, the function values are getting closer to 1 like this. Let's get closer to 1 by picking values from the left side of 1. Let's say here we are picking 0.98. When we plug 0.98 in the function, which is x square minus x plus 1, we get the value of the function 0.9804, which is approximately 1. Let's get closer to 1 on the left hand side of 1 by picking a value 0.99 and see what we get for f of x. When we plug 0.99 in the function, we get 0.9901, which is again approximately equal to 1. So we can see that when we are getting closer to 1, or x is getting closer to 1 from the left side of 1, the function values are getting closer to 1. So we can say that when x is approaching to 1, the function x square minus x plus 1 is getting closer to 1. Or this is the limit of the function x square minus x plus 1 when x is getting closer to 1. Now let's find what is the value of the function calculated exactly at 1. For this, we will consider the function x square minus x plus 1, and in the places of x we will plug 1. We can see that the value of the function exactly at 1 is 1. So here in this case we see that the limit of a function x squared minus x plus 1 is same as the value of the function calculated at 1. So the answer of the limit was 1, and the value of the function exactly at 1 is also 1. So in both cases the answer of f of 1 is 1 and the limit answer is also 1. So limit concept says what is the value of the function when x is approaching closer to 1, and the exact value of the function is what you get when you plug directly in the places of x's as 1. So in the next video you will look at further examples to understand the concept of the limit of the function at a point.